Okay, so now we're going to talk about determinants. And the determinants are a single number that represent the manipulation of matrices. And this is just another example of some things you do with matrices, just to give you a flavor for the subject. So the way determinants work for 2x2 matrices, they're pretty simple. The determinant of the matrix, let's say matrix A, is you take A times D minus B times C, where matrix A consists of 4, this 2x2 consists of 4 elements in the matrix. So you just take these two numbers and subtract the product of these two numbers from it. So for number 1, we just take 2 times 3 minus 4 times negative 2, which is 6 plus 8, which is 14. And the next one's another 2x2, so you take 2 times 9 minus negative 6 times negative 3. So that's 18 minus 18, which is 0. And one thing you can say, why is that 0? Well, if you notice that row 2 is just equal to negative 3 times row 1. So if you get a 0, that means that they're really just multiples. One row is a multiple of the other. Okay, and then 3, you have this times that minus that times that. So you have 0 times 2 minus negative 3 times 6, which is 18. So these are the numbers, the determinant. Now when you get to, to do 3x3 matrices, you've got to do a whole different thing. So minors, when it relates to a 2x2, this is the minor, and it's the cofactor. So when we want to find the determinant of this, all we have to do is, let me just add a page here. So for 4, again, we're just going to take negative 6 times negative 2 minus 7 times 5. So that's 12 minus 35, which is negative 23. Okay, now for a 3x3 matrix, I'm just going to make sure I'm explaining this correctly. Okay, so what it says in the book, it says if A is a square matrix, which it says the minor M sub ij of entry A sub ij is the determinant of the matrix obtained by deleting the ith row and jth column of A, the cofactor C sub ij of the entry A sub ij is blah, blah, blah. Okay. So in this case, you've got 9 cofactors, and they're associated with, this is, if you've got this 3x3 matrix, you've got, this is row 1, column 1, this is row 1, column 2, this is row 1, column 3, this is row 2, column 1, row 2, column 2, row 2, column 3, you've got row 3, column 1, row 3, column 2, row 3, column 3. Okay. So if you were looking for the cofactor 1, 1, 1, 1, what that is these have either plus or minus the signs associated with them. And you start here with plus, and then it alternates. So the next one's minus, the next one's plus, the next one's minus, the next one's plus, the next one's minus, the next one's plus, the next one's minus, the next one's plus. And what they say in the book is it's -1 raised to the sum of the two coordinates. So you'd have 1 plus 1 is 2, so you'd have -1 squared, which would be +1, which is why I have a positive. I remember it just by starting out here as plus and then go minus plus, but you can go the other way, plus minus plus minus plus minus plus minus plus minus, so they just alternate. So the sign of the first one here is positive, and then you cross out this row and this column, and what you have left is this thing. So you have 2, 5, -6, 4. So we take this out and we take that out, and what we're left with is a 2 by 2 part, and you find the determinant of that. Let me just take those off now. So we got that. So the determinant of a 2 by 2 is just going to be 2 times 4 minus -6 times 5. So that's 8 plus 30, so that's 38. So that's the cofactor. This is called the minor. This is the cofactor. Okay, so let's do C12. So that's this one right here. So it's minus. And what you do is you're going to cross out this row and this column. And what you've got left are these two things, 3, 5, 4, 4. Now the way I usually do it is I just imagine crossing this out and crossing that out. What have I got left? I've got 3, 5, 4, 4. So C12 is negative, the quantity, and then we use this cross multiplying thing. So 3 times 4 minus 4 times 5. And that's 12 minus 20, which is -8. -8 times negative is +8. So that's C12. Keep doing this. So the next one is C13. That's the one associated with this, which is positive. So you cross out this row, this column, you're left with that. 3, 2, 4, -6. So that's plus. You've got 3 times -6, which is -18, minus 4 times 2, which is -8. So that gives you -26. So that's C13. Okay, let me go back to here. C21, it's negative. And you take, so we're doing this second row, first column. Second row, first column. What that leaves is -1, 0, -6, 4. So you take this column, this row, you're left with these two and these two. So you've got -4 plus 0 or minus 0, because you've got -6 times 0. So that's -4 times negative, so that's +4. So C21 is +4. Then you've got C22, which is this one right here, second row, second column. It's positive. And then you write out the matrix that's left over. So you cross that out and cross that out. You're left with the 4 corner points, which is 0, 1, 0, 4, 4. So you get positive 1 times 4 is 4, minus 4 times 0, which is 0. So you get 4. So C22 is 4. Then you go C23. It's negative from here. And if you take the second row, third column, you have these two and these two left over. So you have 1, -1, 4, -6. So that is negative, the quantity. Well, 1 times -6 is -6, and -1 times 4 is -4, so you subtract a -4. So it's this times that minus that times that, so that's negative. You got -6 plus 4, which is -2, and negative is a 2. So that's the cofactor of 2, 3. It's 2. Then you have 3, 1. So that's the third row, first column. So that's right there. It's positive. If you mark out third row, first column, you're left with this. So you end up with -1, 0, 2, 5. So that's plus. And then you have -1 times 5, which is -5. And 2 times 0, subtract 0. So you get -5. So C31 is -5. C32, that's third row, second column. Okay, so this one, you've got a negative sign. Cross out this third row, second column. Third row, second column, you got these 4 left. So that's third row, second column, 1, 0, 3, 5. 1, 0, 3, 5. So that's 5 times 1, which is 5, minus 3 times 0. So that's -5. And then the final one, C33, that's positive. If you cross out the third row, third column, you end up with this, which is 1, -1, 3, 2. So you have 2 times 1, which is 2, minus -1 times 3, which is -3. So you end up with 2 plus sign out here, plus 2 minus the -3. So it's 2 plus 3, which is 5. So that's how those work. Now, why the heck do we do that? Well, to find the determinant of a 3 by 3 matrix, you have to come up with these cofactors. That's part of the process. So the last, well, no, it's not the last bunch. So it says find the determinant of the matrix. Expand by cofactors on the row or column that appears to make the computations the easiest. So what we're going to do is we're going to pick either a row or a column, any row or a column, and it doesn't matter. So you choose it to be the easiest calculation. And typically you pick the row or column that has the most zeros. So I could pick column 2, I could pick column 3, I could pick row 2 or row 3. They're all pretty much the same. So let's see, let's just pick column 2 to use. So we're using column 2. So the determinant of this matrix, we'll call it A. The way you do it, so what we're going to do is we're going to just draw kind of like a dashed line around column 2. So you take this number 1, and because it's positive, negative, positive, negative, positive, negative. This one's negative. This will be positive. This one will be negative. So we're going to put a negative sign. So it's negative 1, negative of 1, times, then you do this cofactor thing. So you cross out the first row and the second column. And what you're left with is 3, 3, 0, negative 2, 3. Okay, so that's the first thing. Then you go to the next element in the column, which is 1, but it's plus because we go plus, minus, plus, minus, plus. So it's plus 1, and the 1 comes from this number, times the cofactor that results when you cross out the second row and the second column, because that's where the entry is. So what that, if you cross out those two, it leaves the corners. So you have 1, 2, negative 2, 3. And then you've got your third one, which is 0, times, so if this 0, it's actually going to be minus, but it doesn't matter because this one's going to go to 0 because I'm going to multiply it by 0. That's why you choose columns or rows that have a 0 in, because you have one less calculation you have to do. So, but I'm going to go ahead and show how you do this. So you cross out this row and this column. You'd be left with 1, 2, 3, 0. 1, 2, 3, 0. Of course, it doesn't matter what this is because I'm going to multiply it by 0. So the third term here just goes to 0. And then you do the first part. So you have negative 1 times 3 times 3, which is 9, minus 0, because I've got negative 2 times 0. And then I've got plus 1 here, times 3 times 1, minus negative 2 times 2. So here I got negative 9. So 9 minus 0 is 9. 9 times negative 1 is negative 9. And here I'll have 3 plus 4. Minus and minus plus. So you get 7. 7 times 1 is 7. And the answer is negative 2. So that's the determinant of this matrix. Now it turns out that it doesn't matter which column or row you choose, you're going to get the same answer. You'll still get negative 2. So this choice of which row or which column to use is completely arbitrary. It's the one that makes life easiest, which is usually the minimum number of calculations. So if we look at the next problem, and I'm going to pause it just to double check, make sure I did it right. So let me pause for a second. Okay, yeah, so that's right. What I did is I used my calculator. That's another thing, calculator. Scientific TI 85 4 plus. We'll do is it'll do determinants of matrices. Okay, so we're doing the next one. So you can see what I do is I could either choose row 2 or column 3. So let's just choose column 3. The reason I choose that is because there's a 0 either in column 3 or row 2. So we're going to start here at the top. So the determinant of the matrix, of this matrix A, we take, well, we have plus, minus, plus. So we're going to have plus this number, negative 2, times the determinant of the cofactor by crossing out row 1 and column 3. So that leaves these four. 3, 2, negative 1, 4. And then we have 0, so we don't have to worry about that. So we're going to skip that one. Remember, it's plus, minus, plus, minus, plus, minus, plus, minus, plus. So we have plus 3 times the minor, which is, if you cross out third row, third column, you're left 1, 4, 3, 2. 1, 4, 3, 2. So we get negative 2 times the determinant, which is going to be 12 minus a negative 2, 12 minus a negative 2, plus 3 times 2 minus 12. So that's negative 2 times, here we have 12 plus 2, which is 14, plus 3 times negative 10. 2 minus 12 is negative 10. So that's negative 28 minus 30 is equal to negative 58. So again, I'm going to pause, check that out before. Okay, so that's right. And do we have any more? Yep, a couple more here. So here we have the first row or the third column have zeros, 2 zeros, so that's going to make those real easy. So we'll choose the first row because that seems like an easy one to do. So we're going to choose this row. So for number 8, we'll have it's plus minus plus minus. So this is plus. So we're going to plus a negative 3, and then you cross out the row in the column, and you end up with 11, 0, 2, 2, and the other two are zeros, so we don't even have to worry about that. So we get plus a negative 3 times 11 times 2, which is 22, plus 0, minus 0, so you get negative 66. And I'm not sure I even need to worry about that. Let me just think about this. 2 times. Yep, I tried it the other way. I got the same answer. Okay, now the last one looks reasonably difficult, which is it's not easy. So when you have a 4 by 4, you have to go to a 3 by 3 and then do it. So what we're going to do is we're going to use this row because it has 2 zeros. Now, as far as the signs, plus, minus, plus, minus, plus, minus, plus, minus, and I don't have to go any further because I've already gotten this row. So you start here. So you're gonna it's a plus. So you have plus a negative 2, and what you're going to end up with is a 3 by 3 matrix. So you're gonna cross this out and cross that out, which leaves these 9 entries. So you're going to have 6, negative 5, 4, 1, 2, 2, 3, negative 1, negative 1, like that. So we're looking at this term, cross out this column, this row, you'll end up with these entries. Then you go, this is 0, so we don't have to worry about that. Then we go to the next one. So it's plus minus plus, so it's again plus 6. And then you take this row and this column. So what that leaves is this, this, and that. And then this, this, and that, this, and that. So we're going to have 3, 6, 4, 3, 6, 4, 1, 1, 2, and 0, 3, negative 1, 0, 3, negative 1. Okay, now then what you have to do is you have to do the same thing here again. So because there's no zeros, you basically have to, you can pick any one, any row or column. Here I'm going to pick, let's pick row 3, because that has 0 in it, so that means we have one less calculation to do. And again, you're going to have plus, minus, plus. Here you have plus, minus, plus, minus, plus, minus, plus, minus, plus. Those are the signs. So you have this negative 2 still. And then we're going to take that, and we're going to take plus 6, cross out this row, this column. That leaves, got to do it as a matrix. That was to do as a determinant here. So we're going to have plus 6, cross that out, that out. You're going to have 2, 2, negative 1, negative 1. Then you have negative, because of here, negative and negative 5. Negative and negative 5. Then you cross this row and that column out, and you've got 1, 2, 3, negative 1. So if you cross that out and that, we get 1, 2, 3, negative 1. Then you have plus, because it's this entry, plus 4. And then you've got, you cross out this row and this column, and you're left with 1, 2, 3, negative 1. Okay, well this one, this turns out to be 0, because you're going to have negative 2 minus negative 2. So this part goes to 0. And the reason you knew that, because they were the same. You know, we have the 2, 2, negative 1, negative 1. Okay, so we're going to have negative 2 times 0 for the first one. Then you have plus 5, negative times the negative, and you have 1 times negative 1, which is negative 1, minus 2 times 3, which is 6. And then here you have plus 4 times negative 1 times 1, which is negative 1, minus 6, which is, so you get that again. So that's negative 2. So I'm just doing this one right now. Okay, so you're going to have 5 times negative 7, which is negative 35, and 4 times negative 7, which is negative 28. And if we do that in our calculator, if you get negative 2, negative 2 times negative 35 minus 28, you get 126. So this part is 126. Okay, the next one's going to be easier, because we can pick this row. We have one less calculation to do, so we're going to have 6, this 6, times, okay, 0, so the first one's 0. Then you're going to have this one, which is, we get a negative sign from this alternating thing, times 3. If you cross out this row and this column, you're left with 3, 4, 1, 2. 3, 4, 1, 2. Then you go to here, so it's plus, because it's plus, times a negative 1. If you cross out this row and this column, you're left with 3, 6, 1, 1. Okay, so we've got 6 times negative 3. Here we have 6 minus 4, which is 2. Then we have minus 1 from here. And then we have 3 minus 6, which is negative 3. So that's 6 times, we've got negative 6 plus 3. Negative 6 plus 3 is negative 3. So we get negative 18 from this second part. So the total is going to be 126 from this one, and minus 18 from that, which is going to be 126 minus 18 is 108. So that's the determinant of the original 4x4. So I'm pausing here. Okay, so I did it. I got negative 108 instead of positive 108. So that means I need to go back and figure out what I did wrong. So I'm going to pause you again. Okay, well, actually I learned something here. For 3x3 matrices, it turns out you can do the plus minus thing, but it doesn't work for a 4 4 by 4 matrices. So, like number 8, it's plus minus plus minus, and that's because you take the row, add the row and the column together, and then you raise -1 to that power. So it turns out that this actually goes minus plus minus plus. That's why I was getting the sign wrong. So this is, for example, this -2 is second row, first column. So you take -1 to the third power, which is, because it's an odd power, it's going to be -1. And the same thing's true here, number 6. So I think what happens is, as you go here, you go plus minus plus minus, but then this always goes plus minus in this direction. So you can't just keep continuing on plus minus plus minus plus minus. You have to do that in both these directions and then follow it on. And again, a 3 by 3 works because of the fact that they're odd number of positions. They're 9 positions. So here we have 6, which is second row, third column. So you're going to take -1 to the 5th power, which is negative as well. So -1, so that's a negative. And so through all this stuff, this negative, there's an extra negative there, and there's so there's an extra negative there, so this becomes negative. And likewise, this one's going to be negative here, and you get a negative there, so that's plus 18. And so this becomes a -126, it's plus 18, so you get -108. And that's why my answer was not working out. So now I know. Okay, and the last bunch of problems, you're asked to find the determinant of A, the determinant of B, A times B, and then the determinant of A times B. So the determinant, this is number 10, the determinant of A is going to be equal to -8. 4 times -2 minus 3 times 0. So that's the determinant of A. And the determinant of B is going to be -1, 1, -2, 2. So you get -2 minus a -2. So you get -2 minus a -2, which is going to be equal to 0. So if we take A times B, so you take first row, first column, that's 4 times -1 plus 0 times -2. So that's going to be, and this is a matrix because it's matrix multiplication. You get -4. Here we get 4 times 1 plus 0 times 2, which is going to be 4. Second row, first column, you get -3 plus 4. That's going to be plus 1. And you have 3 minus 4, which is -1. So that's A times B. And then you can take the determinant of A times B. So that's -4 times -1 minus 1 times 4, which is 0. So if I multiply the determinant of A times the determinant of B, I'll get 0, which is the same as the determinant of A times B. Now, I don't know if that's something you can generalize or not. Okay, and then the final one, we got these 3 by 3 matrices. So we're going to need to do the matrix of the determinant of A, which is going to be easy. We'll pick the first column. So the determinant of A is going to be 0 plus minus, because it's plus minus, so it's going to be minus a -3 times, if we cross out this row and that column, we'll end up with 1, 2, 4, 1. Because across this row and this column, you get 1, 2, 4, 1. And then you get 0 plus 0, from this one. So we just have this middle term. You'll have 4. 1 times 1 is 1, minus 8 is negative 7. So you'll have positive 3 times negative 7 is equal to negative 21. So that's the determinant of A. So we take 0 minus negative 3 across the row at second row, first column, 1, 2, 4, 1. When you do that, you get negative 7. Negative times the negative is positive. 3 times negative 7 is negative 21. Okay, B. We just use row 1. So you can have 3, and the matrix you have left over when you cross out row 1 and column 1 is negative 1, 2, 1, 1. Then you have subtract, because it's the second, plus minus. So it's going to be negative 2 minus the negative 2. And then you have, cross out this row in this column, you have 1, 2, 3, 1. 1, 2, 3, 1. And then finally you have 0. 0 times something. Well, you'd have 0 times 1, negative 1, 3, 1. But it doesn't matter what this is. You're going to get 0 at the end. Okay, then we have 3 times the determinant of this, which is negative 1, minus 2, which is negative 3. So we'll have 3 times negative 3, and then we'll plus 2. Negative times negative is positive. And the determinant of this is 1 minus 6, which is negative 5. So that's negative 9 minus negative, or plus negative 10 gives you negative 19. Okay, now we're going to multiply A times B. That's a matrix. It's a 3 by 3 matrix because this is a 3 by 3 multiplied by a 3 by 3. Because these are the same, we can multiply them, and the outside numbers are the dimensions. So I'm going to just do this. So you take row 1 times column 1. So you've got 3, 0 plus 1 plus 6, you get 7. Okay, take first row, second column, so you're going to get 0, negative 1, plus 2, so you get plus 1. Then we take first row, third column, you get 0, 2, 2, that's 4. Then you take the second row, first column, so you'll have negative 9, negative 11, negative 8. Then you take second row, versus second column, you're going to have 6, 8, 8, let's try this again, 6, 8, 12. And second row, third column, you have 0, negative 4, plus 1 is negative 3. And then the last one, you take third row, first column, so you have 0, 4, 7. First row, second column, you're going to have 0, negative 4, plus 1 is negative 3. And then you take third row, third column, so you have 0, 8, 9. So that is A times B. And then to do the determinant of A times B, you're going to have 7. Doesn't matter, I'm going to use the first row. So you cross these out, you're going to have 12, negative 3, negative 3, 9, minus 1. So you take this one, cross out this row, this column, you'll end up with negative 8, negative 3, 7, 9, plus 4. This is 4. Cross out this row and this column, you end up with negative 8, 12, 7, negative 3. Okay, so let's just So then you take the determinant of this 2 by 2, so it's 12 times 9 minus negative 3 times negative 3. So you get 7 times 99 minus 1 times, okay, and you have negative 72 plus 21 is negative 51. So it's negative 72 plus 21. And then you get 4. Here we get 24. Negative 8 times negative 3 minus 7 times 12. So that's negative 60. So we take 7 times 99 minus 1 times negative 51 plus 4 times negative 60. And we end up with 504, which is not equal to, well, let's see, 21 times 19. Negative 21 times negative 19 is 399. So if we take the determinant of A times the determinant of B. Now, while we're doing this, I'm going to show you something. This is a program that does matrices. And what we'll do is we'll do that last problem just to make sure we did it correctly. But you can see how this thing works out. I'm just looking at the problems so I can copy them from the book instead of me having to look back and forth. So what I'm going to do is I'm going to define matrix A and use these square brackets. And A is 0, and you use commas to separate things on a row, and then you create another row. And let me make sure I'm doing the right one here. 0, 4, 1, yep, okay. 0, 4, 1. I push enter and it should show me the matrix, and I can double check it's right. Okay, so that's matrix A. Then we say matrix B equals, put a little square bracket in there, 3 comma negative 2 comma 0 semicolon 1 comma negative 1 comma 2 semicolon 3 comma 1 comma 1 right bracket. Just checking to see if it looks like what it did. Okay, so that's matrix B. Now what you can do is the determinant of A and push enter, and you get negative 21, which is I think what we got. Negative 21. Okay, great. Then we can say what is the determinant of B, and that's negative 19, which is, I know the answer. Then we can also take A times B, and that should be get what we got. 7, let's see, A times B is here. 714 negative 8, that's one error right there. 9, that should be 9. 7 negative 3 9, 7 negative 3 9. Okay, so that, let's fix that. That's 9. Okay, so let's go back and see what we get here. So I need to change, I guess where it was 12, I have to put in 9. Okay, and then let's fix these here. I think these two were the ones that I changed to 12s. So here we have 81 minus 9, which would be 72. So 9 times 9 is 81. Minus 3 times negative 3 times negative 3. So it's 81 minus 9, which is 72. And here we have 24. Negative 8 times negative 3 is positive 24 minus 63. So 24 minus 63 is negative 39. Okay, let's see what we get now. So I have 7 times 72, then you get plus 51, and 399. And if we take 21 times negative 21 times negative 19, we get 399. How about that? So let's go back, and the only thing that we have to do now is find the determinant of A times B. So A times B was this that, and if you did determinant of it, you should get 399, which is what I get. So that all works out. So interesting. So if you do the determinant of the matrices separately, then multiply them together, and then find the determinant of the product. It's the same as the product of the determinants.